Okay, so today you can see that we did these yesterday. But what didn't we do yesterday is work with the A and the D. Now the A and the D throw a pretty big curveball into this stuff. So that's why I want you to think about what A and D used to mean before. C and D, sorry. What C and D used to be before. Okay? Now, if I had y equals x sine x minus 30 degrees. Okay? What do you think that means? Okay, don't yell it out. I want you to think about it. I'm going to pick somebody. What do you think that means? Well, go with what you know. If I would have given you this 3 months ago, you should have been able to do it. Yeah, that's right. We were going to do what, though? What was the first thing we always said? We're going to do a horizontal translation 30 degrees right. Okay? Now, we before were saying horizontal translation 30 degrees right. Erin, did we rehearse this before? The answer is no. I asked her, she could do it. Okay? I'm hoping all of you are going right now, okay, yeah, that makes sense. Now, do you see how that thing in the brackets, that belongs to who? And sine. Okay, that's sine. So it'll always be messing with the angle. So that will either be in degrees or radians, depending on what mode you're in. Okay, now if you see x minus 30 degrees, that's another indicator. The domain should be between 0 and 360 degrees, but that's another indicator that we're in degrees. Now, there's one change that we're going to make today, and instead of calling it a horizontal translation, it's going to be called a horizontal phase shift 30 degrees right. Okay? Now, do they mean exactly the same thing? The answer is yes. This is just more specific to trig. Okay? That's okay. Now, of course, this is the question that came out, so maybe you're thinking it now. What if I'm on a test and I do horizontal translation 30 degrees right? Am I going to get it wrong? Okay? Well, if it was a quiz, I'll mark it wrong. If it was a unit exam, I'm hoping that because you got it wrong in the quiz, you're not going to do it again. Why do I need you to know that horizontal phase shift means the same thing as horizontal translation? It's because you're not going to be happy with me when I mark it wrong in the quiz. I get that. But if I cared about your short-term happiness, I'd give it to you. Good. And you would do it. And maybe you wouldn't even recognize that. What's horizontal phase shift? I can't remember that. Okay? But if I made you use it and made you use the new language, then you're going to be better on the diploma. And let's face it, you get to rewrite quizzes. You don't get to, well, you do get to rewrite a diploma. There's just a few other restrictions on it. And there's a different effect when you fail a quiz or don't do well in a quiz as opposed to don't do well in the diploma. Okay? One should hardly bug you at all because at noon hour you can fix it. So we're going to ask you, I'm going to ask you to please do horizontal phase shift when it is trig. Okay? Now, we also have different wording for when that messes with the y. Now, can you see why that 2 does not belong to the x? There's no brackets. And it's, you just can't put things in like that, okay? So this is the same thing as y minus 2 equals sine x. So then I know y got replaced with y minus 2. So that was a vertical translation 2 units up, right? Now we're going to call it a vertical displacement, 2 units up for trig. Okay, that's all we're doing. You know what it means. We just want to use that language so it's consistent and you are familiar with it for the diploma. Because it's not a phase. A phase usually means in degrees or radians. Okay, and the displacement is how much that, when we do normal things, we don't know where it normally goes. If you just gave me like x squared plus, I don't know where it normally goes. But where is sine always supposed to be? On the x. Okay? Sine's always cruising on the x. If you're moving it, you are displacing it. Okay? So that's why it's kind of getting a bit more specific. Okay? Now, let's go to the next page. And here is all of the things you need to know, right? Horizontal phase shift, the left, the right. This is all the rules that you know. The only thing that's been changed is instead of horizontal translation, it says horizontal phase shift, and vertical displacement used to be vertical translation, right? Just remember, for period, it's 180 over B410. Okay, so what we're going to do now is we're going to do 2 questions, kind of 1.5 questions, with everything in there and see if we can do it without me even teaching it to you. Okay? So if you get it wrong, it's no big deal. I never taught you, right? If you get it right, that might prove that you knew it all along. Now we're going to do B for both of these. Okay, now this one is an ugly question. It used to drive me nuts when I used to take math and the teacher do this nice little quick easy question. Everyone get it? Yeah, we all got it. Then he gave us the homework and we were like, what? This one has like 10 times as long as the first one. And the one he gave us, I don't want to do this one. So this one should cover the hardest one you'll ever see. Because it's, and B is a little bit harder. Now, this one here, can somebody tell me how to write it? You know the way I always like it. Y's with the Y's and the X's with the X's. Okay? Okay, actually I'm not going to, I'm going to pick somebody here. Ashley, how would you write this? So all the Y's are with the Y's and the X's with the X's. Okay, that's awesome. Okay, now if you want to know the algebra, the first thing you got to do is minus 3 to both sides, right? You do that first, then you multiply both sides by negative 3 over 2. Okay, next person's going to give me the replacements. Person after that is going to give me the words. Now, remember, this is what we started with. Okay, so it's a little bit uglier than that, and that's why we got to describe what happened to y equals cos x. Now, does everybody remember what y equals cos x looks like? Okay, it does this, right? And then it keeps going. But that's a y equals cos x. And this is a little bit different than that. So let's see what happens. So first of all, we're going to do the replacements. Then my next person is going to give me the words for it. Okay, Emily R. Replacements. Okay, so you want to start out with reflections. SRT. SRT. Do that horizontal stretch. Oops. Okay, good. Okay, so we don't do it from left to right. We do it SRT. Now, she did RST. That's cool, because I said that still works. Now, the lucky person. Lucas. So, starting with, we're going to do it in the order that she gave it to us. Go. Hold on. Okay, let me put vertical stretch by 2/3. What would that? What's the rest of that? About. Okay, next. Vertical. How many? Oops. Very nice. That's it. Is that consistent with the first unit? I know I would have a lot of ugly looks right now if it wasn't. Okay, now I want to know. Okay, we're not doing A, so we got, but I want to know what's the amplitude of this. Krista, what's the amplitude? Okay, I want to know what the period is. Oh, we just did a quiz on that, so hopefully. Kayla, what's the period? Tell me how to do it. So that's the same thing as 4/1. Do you know what I mix up on these sometimes? Is I want to divide by pi/12. Okay? So if you do that, that should be on your study sheet. Don't do this. Don't divide by pi/12. Do you see the pi/12 here? If I'm not thinking, I see this pi/12 here, and I'm thinking, hey, that's, remember he said, you just take that and divide it out. It is going to be the b value you divide out. Remember? This is the c. So am I guilty of that? Absolutely. Yep. Ding, ding, ding. Always. Always. The only thing, well, not with tan. Tan has no amplitude because it goes forever. He almost got me on that one. Okay, but remember that when we are doing tan period, we must divide by pi. Okay, the next one, I'm going to give you like 14 seconds to get that, the y's with the y's, the x's with the x's. That's 13 seconds more than you need. That's me. Give, give, give. I don't want any more. I just want y's with the y's, x's with the x's. Okay. Amy, can you just give that to me? Okay, so you obviously knew where I was going with that one. Why would I give this one as a another example? Because remember, x should never have something in front of it. Only if it has no horizontal translation, that's fine. Like if it was just cos 2x. Yeah, I get it. Of course it's 2. You can take out the 2 if you want, but you know. So that's the only catch with this one. The rest you should know how to do. It's actually identical to the one above as far as steps and things like that. Okay? But what happened, make sure you are pulling out the 2. And bringing the minus pi over and then the minus outside. And you see that it is set up nice on the left. That's good. The right, you had to take out that 2. If you guys remember this step, okay? Will there be one in the diploma? I bet you. Okay, now the fun. If you thought this was fun, hold on. Okay. We're going to do 2 examples of you looking at a graph and being able to give the equation. Now, I think that's a pretty cool skill. If you guys walk out with that, right, that is something that just makes you feel that much better in the diploma. You can just look at a graph and you know exactly what it is. Now, remember, if you don't know where you came from, you're probably not going to be able to give instructions to someone of how to get there. And if you don't know what there looks like, it's even harder. So this question right now says, write the equation y equals a sine x minus c. Okay? So nice. Not even asking me for a b value and not even asking me for a d value. Okay? Now, let's go with my patented steps. So number 1 is always draw original. In this case, we're doing y equals sine x. If you don't know what y equals sine x looks like, then this is going to be pretty useless to you. Now remember, y equals sine x starts at 0. Now here's 1 and here's negative 1, right? And it goes at pi over 2, it's there. Then it comes down, back down to 0 at pi. And then at 3 pi over 2, it's negative 1. And then it comes back to 2 pi. So here is what it started as. Now, that's not like the ones we've done before. They come up nice and but the other ones didn't have y values that went up to 4. It will look different, but that is what you got to be able to put down first, and then you're good. Now, number 2, which is the most important part that students struggle with, and if you can't do number 2, you will not get these questions right. Number 2 is establish, see, big word already, intervals, or increments, I should say. Okay. Now, what am I talking about? 2 big words. Okay. In other words, tell me what each tick is. Each little line on the graph. Now the 1 is easy. Okay. It's the x that's always going to cause you problems. Anybody, let's do this from a student's point of view. Anybody know a way to find out what every one of those ticks is? Because they're going to change them all the time on you. Like, you know what I'm talking about by the ticks or the lines? I'm talking about this one, this one, this one. How do you find what each one is? It's pi over 6? How did you get that? So 0 and pi is the money. Find where 0 and pi is, count how many ticks there are. Now, Lucas, according to you, then what would this be if you were counting by pi over 6s? Yeah. Right here, that's a pi sign. Yeah. But since you're counting 1, 2, 3, that would be 6 pi over 6. Make sure that works out that way. Okay? So, establish the increments. You want to take pi and divide by the number of ticks, right? Or which will equal, in this case, pi over 6. Just make sure that 6 pi over 6 is there when you count them out. Okay? Because if there was just 2 of them, and you went 1 pi over 6, 2 pi over 6, 3 pi over 6, I should be at, so it's by 3's, right? Because that's 3 pi over 3, okay? Now, I'm doing this slow because I want you all to get it. You need to be able to know how to draw a sine graph and know how to find your increments. That is huge. Now, we can tell the left or the y is going by 1s, okay? They're not going to get crazy on us there. They may have a 1 and then you got to go by 0.2s, but you guys should be good at that. It's this one that, or the x, that people do struggle with. Now, I want you to kind of picture what happened from that blue graph to make the other one. Now, the question that I would ask is, or the big question I would ask, is did it move up or down? Did the graph move up or down? Why? Someone give me a mathematical explanation of why not. Yeah? Right. Okay. What he's saying is the distance from here to here is the same thing as here to here originally. Well, the distance from here to here is the same thing as here to here. If this moved up 1, did you see how this would be like 3 and this would be 5? Okay. Now, what's a good name for the middle of a graph? You know what I mean by the middle? Same amount on top, same amount on the bottom. What would be a good name for that? Middle? Yeah. One word though? It's called midline. The midline is the center. And if you go back to here at the bottom, this is called D. That's your max plus your min divided by 2. Max plus min divided by 2. What are they finding when they add the top and the bottom and divide by 2? Yeah, the midline, but more average. Amplitude is max minus min over 2. Right? Not the same. So this is called the midline. Okay, and I'll tell you, the midline is the most important thing to look at. If you do everything from the midline, it will all make sense. Now, I always give this example because anybody that's ever been in these sports will know what I'm talking about if you've ever been coached about this. But if you ever have, if you play hockey, you play soccer, you play rugby, you play football, if a football player is coming to you with a ball and you have to tackle them, okay, what are you supposed to focus on? What part of their body are you supposed to focus on? Yeah, chest and actually the center part. That's the middle, right? If you focus on the ball, they'll get you every time. If you focus on the puck, they'll get you every time. Because you're going to go for the puck on that side, then he's gone. I mean, that's exactly what he wants. But if you focus on the hips, he's not going around you. And that's all that your job is. Okay, if you're a defenseman, right, you stand there, don't let him go through. I don't care where the puck goes, because you don't have it anymore. Okay? I'll go get it after. Same with football. You don't care. I mean, it's nice if you can get that ball in a fumble, but your job is to tackle him, get that done, don't get fancy. And in fact, if you're trying to get that ball, you're most likely going to get yelled at when you come back to the bench, because why did you let him go? Okay? So if we always focus on the middle of the graph, these are so much easier to do. In fact, by looking at the top and the bottom of the graphs to try to figure out what happened, you'll get psyched out. Okay? Now just trust me, because I've done these enough. I know what students, if they're focusing on that stuff, they always get messed up. So the midline of our original graph was here. Our midline of our new graph, let me get my fancy line, is here. Okay? I've just made it a little above. But don't you see it didn't change? That's my D. It didn't move up or down. And I don't care how much the top moves up and down. The middle didn't move up and down. You can argue, oh, top moved up. Well, the graph didn't move to move that up. It was stretched vertically to move that up. Okay? That's how I know the difference between a vertical stretch or a vertical displacement. Okay? Now, the other thing I look at is, do you see how the floor, see from the y-axis, it was touching the y-axis. It goes through. Now the new graph, compared to the midline, it moved, didn't it? It moved 3 increments. It moved 3 pi over 6s to the right. 2 pi over 6s to the right. Okay, do you see how obvious it is when I make a mistake? I was like, what? I was getting this. I thought I understood this. Where did the 3 come from? Okay? It moved 1, 2 pi over 6s to the right. Does that make sense? If you look at the midline from the y-axis. But we still are going to do it in SRT. Okay? So the first thing, I could tell that thing was stretched by a factor of 4. Okay? So that is a vertical stretch by a factor of 4. So y gets replaced with 1/4 y, right? What is that going to become when I make it y equals? If I bring it to the other side, it would be y equals 4 sine x minus c. What is 4 supposed to stand for? Guys, what does it stand for? Amplitude. Does that make sense? Okay, good. There should be a couple things going on all the time. You're going, okay, yeah, fits there, good. We have that old unit that we can't change the rules now just because we're in trig, okay? All we've done is change the names of it for a couple things. The second thing, there is a horizontal translation because it used to be on the x, or sorry, right, touching the y-axis right at 0 there, and it moved to 2. So that is a, what happened? Horizontal phase shift 2 pi over 6, sorry, which is pi over 3 units left. Okay? So this would be y equals 4 sine x. Yeah, right, sorry. X minus pi over 3. That's your equation. Okay? Yep. Where are you writing to? Oh no, don't do 2 units, because it's not 2 units. That's why we had to establish that increment right from the beginning. Now, we're going to throw, just in case this was making sense, we're going to do B. B says they have a new restriction for us. They're saying, you need to make me that graph but A has to be negative. Now I know what you're saying. Oh, we'll just fit y equals negative 4. Sine x minus pi over 3. That's so easy. That won't get you that graph up there. So we have to make it negative. What are they asking us to put into this? A reflection on the x-axis. So this is a y is getting replaced with negative y, isn't it? So that's a reflection on x. So let's draw our original graph. Oops. Wasn't good. Should be going right through pi. Okay. Now, can you take that and reflect it? Okay. Now, what should we do next? What would you do next? I gotta make it look like that black curve there. What did you do next, guys, to start making it look like that? I did the reflection. What kind of stretch? How much? Vertical stretch by 4. So then if I did that, I'd have like this, right? Then what would I have to do? Talk to me. Well, what do you do next? No, I need to better than move it, okay? We should be past that at this point. Chelsea, what would you do? To the left, right? Instead of, so you'd go 2 pi over 3? Okay, well, each one is a pi over 3, right? I got to go 1, 2, a pi over 6, sorry. 1, 2, 3, 4. Okay? I actually didn't disagree with you. I just wanted to make sure everyone could, like 2 pi over 3, how'd you get that? Okay? So, if you know your increments, that helps. So, we had to move 4 pi over 6, which is 2 pi over 3, to the left. Okay, so what would be my final equation? Dun, dun, dun. Trying to. No, this is good. I like this. We'll move it after. Okay, so you can give me the final. Okay. Now, come on, face it. This is a great question. They got to do, like, who's going to get between 80 and 100 on the diploma? It's going to be the person that knows how to do questions like this. What? It's got to be a negative A. I mean, I don't know. I got the one with the positive A, so I'll just put a negative in front of it, and that's all I'm going to do for that one. Then you're going to walk out into the atrium, and someone's go, did you get that one where they wanted negative A? I didn't know what to do, so I just put a negative there. No, all you have to do is a reflection and then do all the other stuff. And then you're kicking yourself when you get out because you're like, it was that easy? That's all I had to do? So, good question to be able to do in our notes. Okay, now let's do a real question here. Okay? This one is not for the weak. I would turn your eyes now. They always say that before they show that sports video, you know, where the guy gets a leg twisted and bone splits right out, and they're like, if you know your stomach's a little bit weak, don't watch this now, right? There's people who aren't even going to watch it, or they're going to watch it now because they're told don't watch it now. Okay? Everyone loves to see the train wreck. Well, this is kind of like a train wreck. Haven't you ever seen those in the sports? When someone gets tackled and their leg breaks in the tackle and they show it? No? I got to get out more. Okay. Now, the question is to represent this sine function. Okay? So, if this is sine x, the first thing I should do is draw sine x. Remember, that was my first step. Try and have a plan when you do these things. Remember, always know where you're coming from. It's pretty obvious, I think, if that's where you're going to... Now this one, you see how it's like goes up... Oops, sorry. Pi over, that's going to be about there. And then, I guess that'd be... So this is what it used to be at one time. Now, the person that is not focusing on the midline is going to say it moved over just a little bit, right? It only moved over, like, look how little it moved. Right there. It hardly moved at all. So, the important thing is don't look at that. Don't look at where the maximums moved left to right, because that's irrelevant. The second thing was my x increments. Okay, what is each one of them? Pi over 3. So if you count 1, 2, 3, you should be on pi, which is 3 pi over 3. 4, 5, 6 over 3, 7 over 3, 8 over 3, 9 over 3, 10 over 3. Okay, that's how you're going to do these. Now, this was the midline. Okay, my midline slipped. Now, you can do it by visual. You can do it by max plus min divided by 2, which is an average, right? If I wanted to find the average between two marks, I add them together and I divide by 2. That'll give me the middle. What is the middle of this graph, the new one? -2. Good. And it should visually look like -2. Make sure your amplitudes are in the same top and bottom. That tells us, that's going to help me so much with what? What does the midline really help you with? With which two letters? D and? Does it help you with A or B? It could help you, but the stretches are done before it's moved, right? So we know that the stretches were done from the X and from the Y. It's after it's moved, I can tell you how much it has now been slid around. So first of all, what would be my vertical stretch? What would it be? So you can look from the midline what it was at the beginning and now at the end. What's the vertical stretch? Just yell it out. It is 3? Is it 2 or is it 3? Is it 4? Should be 3, right? Because vertical stretch matches what? Amplitude. And I think it's, if you count, that is 3. Now, horizontal stretch. Anyone got an idea how to even do horizontal stretch? By looking at it? Yeah? Mm-hmm. Yeah, that's one way. The other way is, that's definitely, there's a couple ways to do it, but if you looked at this distance here, what is this distance? What is that distance? Right here. It's pi, correct? Right? Now, that's supposed to match this distance here, right? You see that one? That is, and you can count them because it's pi over 3, right? So if you want, you can go 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. Oh, it's 2 pi now. So pi went to 2 pi when it was stretched. Therefore, what is my horizontal stretch? 2. So horizontal stretch by a factor of 2. Why? Because pi distance went to 2 pi distance, right? Now you could have done, it went from, you could have done the whole thing. Well, it was 2 pi, went to 4 pi. You know, just the first part of the period. Now, the rest, okay, we're not going to work down in B here, so we can use it for horizontal shift or horizontal phase shift. Now remember, we look how far it moved from the y-axis. See, what happened was there was a vertical stretch, still stays attached to the y-axis. Then there's a horizontal stretch, still stays attached to the y-axis. Then you can tell it was moved down and to the left. How far? Pi over 3 left. Is each tick pi over 3? Yes, we established that already. So we do have a horizontal phase shift. Pi over 3 to the left. Okay, so remember, it was, oh, somehow my entire graph moved a little bit here. Come on, here, close enough. So it was right on the x-axis, then it moved 1 to the left, right? Or y-axis, I should say. It was right on the y-axis, and it moved 1 away from the y-axis. So you look at how many is it away from the y-axis, and it's 1 away. Okay? And it went 1 to the left. Now, 1 unit, one of the things, the 1 pi over 3 to the left, one of the increments. And how about vertical displacement? Now it's nice because vertical displacement, now we have D, right? V, so D matches. So the vertical displacement is how much did the midline move? So this is midline move. How much? So how many? 2 units down. Any questions of how I got this wording? Now the next thing I need to do is I need to change this to replacements. So vertical stretch by a factor of 3 would be y goes to 1/3 y. Horizontal stretch by a factor of 2 would be x goes to, what is it? Half x. Okay, horizontal phase shift, pi over 3 left. X goes to x plus pi over 3. Vertical displacement, y goes to y plus 2. Okay, so it should be, we're really working weird here, we're working to the left, but that would be 1/3 bracket y plus 2 equals sine 1/2 bracket x plus pi over 3. Final equation, y would equal 3 sine 1/2 x plus pi over 3 minus 2. Now, how on earth you'd fluke that off, I don't know. And that's why I'm telling you, people really, really try when they get to that diploma. I mean, they haven't been to class all year, so they're like, I've saved up for today. I'm going to put in so much effort, it's going to be awesome. Okay? They try really hard, and they're not able to come up. You know, this entire question, they could just ask you, you know, after it's all done, what's A plus B plus C plus D, round to the nearest tenth, put it in the box. There's no way you're getting that one right. Right? I mean, if you really, really, really know what you're doing, there's a chance you're going to make a mistake. Okay? But how are you going to fluke this one off? I'd love to see it. But wouldn't that be just a horrible numerical response question? The sum of A plus C plus D, you know? It's like, it's a great way to just, here's a picture, get in the form, you know, sign, and then add them together. Now, we're not totally done. By looking at my final equation, what's my amplitude? What is it? 3. Okay, what's the period? Hello? What's the period? 2 pi? Oh yeah, 4 pi. Okay, who got 4 pi? And how? Miss Goings, tell me how you got yours. What'd you do 2 pi times 2? Okay. What's your half? Where'd you get that? So you did 2 pi over half. What is 1/2? What's the formula? It's 2 pi over b. Good. So then you got 2 pi times 2 over 1, which is 4 pi. Can anybody give me another way you could find Remember how I showed you yesterday when we first started? What's a way you can find period? It's got a nice easy way to find period is go. Remember, like peak to peak? Do you remember that? Remember that little talk? You could go like this. Okay, well let's count. Now these are pi over 3s, right? 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. 12 pi over 3 equals 4 pi. Okay? Another way you even get to check if your equation's right. Do you see how if you know your stuff, how much more creative you can get in checking your answers? But that's like the most basic way to find period, right? Most basic way to find amplitude. Okay? How's that? I cannot see you getting a harder question than that. I just can't see it. There's the picture, bang. You know, get into the equation. Will I give you one on those, one of these on the unit exam? Would you, seriously, give one of those questions if you're writing a unit exam? I guess that's why you're not me, because I would. Okay, now this is a really good question. Because now that we have done that last one, this should be a bit more clear. Now remember, just so you know, we're talking about sine graphs. What do sine graphs do? They go like this, right? You know, what's the big deal that it goes to 0, 0, right? Where 0, 1 is where your cos does its intersection to the y-axis. Okay, that's your two graphs, your sine x, your cos x. So, like, this is a really good question because your calculator can't just do it. I mean, you have to actually think about this one. Now, if we change A, B, C, or D, which one of them affects the domain? So A is amplitude, right? If that's bigger or smaller, does that affect the domain? No. How about B? B stretches it. If we stretch our graph, does it have a different domain? No. How about if we do a vertical translation on it? So we take that graph and we move it up. Does it affect the domain? Okay. Last thing, what happens if I take the whole graph and I just move it left? Does it affect the domain? Okay, that was right. You're left. Okay. But I'm moving it all to that side. Shouldn't my domain be, it could be infinity plus 2/3, right, I guess? But that's still infinity. So how's my domain changed? No. So which of those parameters actually changes it? None. Okay? Does that make sense? Now, which one of those affects my range? Which one affects the range? Does amplitude affect the range? If I stretch it like this, does the range change? Yeah, I'm with you on that one. Okay, is that it? If I take my entire graph and I move it up, does it affect the range? Yeah, so just D, right? Which one affects the amplitude? Okay, what about D though? Why not? Yeah, what is amplitude? It's from D to the maximum, right? If I move that up, that's not changing. Okay? Anything else? Okay, which one affects the period? B? Nothing else? Okay, which one of these affects the zeros? Does A? If I go like this, does it affect the zeros? How about B? If I take it and I stretch it like this, does it affect the zeros? Yeah, so B does. How about C? I move it to one to the left, or yeah, it would be, yeah, it affects it. How about D? Would D change it? Okay, so I got a bit of a disclaimer. It can be A. Okay, the reason being is, say they told you to do A, because they can tell you to do it out of order. What if they told you to move it up, say, 3 units, right? And you were like this. This is your graph after you moved it up 3. Now, if they then tell you to do a vertical stretch by 4, what would happen? It would change my okay, now it does change the zeros. So what is the disclaimer? I would say A if D does not equal 0. So if there is a horizontal, or sorry, a vertical translation on it, A does affect the zeros. Yep. Yep. I'm just telling you that if they say, do this first, do D first, then do a vertical stretch. Because remember, do them SRT unless told otherwise. Okay? Now, state the maximum and minimum values of this graph. So y equals a sine b x minus c plus d. I want to see how good you can think generally. How can you from this formula find the maximum value on that graph? Okay? Come on. Somebody try. This is a good thing to know. How would you find the maximum value on this general graph? A plus D, very good. D is your midline, right? You take D plus A, you'll get your maximum value. Okay? So your max is D plus A. What would your minimum be? D minus A. Okay, so I don't care where this thing is. You give me the D and the A. I will figure out the maximum, and I'll be able to figure out the minimum. Okay? It could be floating anywhere. You give me the D, I can do the max or the min. Okay? Now, what would be the range of this function? Okay, well, let's find the max. The max would be what is it? How would I figure it out? Yep. What is it in this one, though? Yeah, now I would go -4 plus 3. Look, I know you said the same thing. I'm just thinking D plus A, D minus A, right? So D is -4, so then that's -1. The min is -4 minus 3, which is -7. Okay? So it asks me the range, y is greater or equal to -1, less or equal to -7. Okay, so we're doing 1 ACE, and 2 to 12. Pardon? Yes. No. Yeah, right. That's what happens when I start thinking too far ahead. I wasn't concentrating. Okay, so y is greater or equal to -7, less than -1. Like if you want to get right into some good stuff while you're in class, start with number 3. Okay, do number 3. Those are the hardest questions in the homework. can grab the lights there. Okay. That's it. Can you grab the lights? That she was going out. Thanks, Ian. I know you got my back.